Properties of binary operations. In this module, you will learn some properties of binary operations. Recall that a general binary operation represented by star on a set S associates two elements from the set S in a definite order to an element of the same set S. We can represent a binary operation star on a small set A using a table called an operation table. Let's understand, using an example, how we read this table. Suppose we need to find 1 star 4. It equals an output in the first row and fourth column, which is 1. Similarly, 4 star 1 equals an output in the fourth row and first column, which is again 1. Likewise, 2 star 4 is 2, which equals 4 star 2. 3 star 4 is 3, which equals 4 star 3. Similarly, 4 star 4 is 4. So, we can observe that the star operation performed on a number and 4 or vice versa equals the number itself. So, 4 is the identity element for the binary operation star. This helps to generalize that an element E belonging to a set X is an identity element for the binary operation star if A star E equals A, which equals E star A for all A in the set X. Here is an easy way to look for the identity element from the operation table. The row or column of the identity element exactly matches the row or column headings. Now let's learn what the inverse of an element is for a binary operation. Can you guess which element we will pair with the 2 to get the identity element for? Well, it is 3. 3 is called an inverse of 2 as the star operation performed on them gives the identity element 4. Similarly, 2 is inverse of 3. 4 is inverse of 4. And 1 is inverse of 1. Now, we can generalize that an element A belonging to set X is invertible for the binary operation star if there exists B belonging to the same set, so that A star B equals the identity element E, which equals B star A. Also, element B is called the inverse of A, which is denoted by A raised to the power minus 1. Now let's understand what commutative binary operation is. From the table, we can see that 1 star 2 and 2 star 1 equals 3. Likewise, 4 star 2 and 2 star 4 equals 2. Similarly, we can check for other pairs. We can see that when the binary operation star is performed on any two numbers in any order, the result is the same. such binary operations are called commutative. We can generalize that an operation star on a set X is commutative if A star B equals B star A for all A, B in set X. Here is one easy way to find that the operation defined by a table is commutative. Draw a diagonal line from upper left to lower right like this. If the table is symmetric about the diagonal, the operation is commutative, otherwise it is not. Now let's look at associative binary operation. Suppose we need to find 2 star 1 within parentheses star 3. For this, we first find 2 star 1, which equals 3. Now find 3 star 3, which equals 1. Next, find 2 star 1 star 3 within parentheses. Since 1 and 3 lie within parentheses, first find 1 star 3, which is 2. Next, find 2 star 2, which is 1. So we can see that the binary operation star is associative for 2, 1 and 3. We can check if the binary operation star is associative by considering all possible arrangements of numbers from the set A. If the associative property fails for even a single arrangement of numbers, the binary operation star is not associative. Now we can generalize that an operation star on a set X is associative if A star B within parentheses star C equals A star B star C within parentheses for all A, B, C in set X. In this module you have learnt to define identity elements for a binary operation, inverse element for a binary operation, commutative binary operation, associative binary operation.